Hi everyone, welcome to this quick video on how to use the Excel-based Lean Six Sigma analysis tool for an ImR control chart. And the ImR stands for Individuals Moving Range Control Chart. So here we are. Really quickly, when you open up this file for the first time, you're going to come to the Setup tab. This is the first tab you want to input some information around your process. Now keep in mind for any control chart, we're not going to get into the theory around control charts, but whenever you're measuring something in your process in a chronological fashion, control charts can be super helpful to understand a lot of the base variability in your process, to look for stability of your process and various other trends. Okay. And so in this case, if I'm measuring, let's say, product weight from a factory, and I'll use this example through the other tools as well when we do some videos on them. If I'm measuring product weight in my factory, and I'm capturing the products as they come off the line chronologically, you could use an ImR chart to plot the data and see what you find. Okay. So when you open up the tool for the first time in Excel, you fill out the setup tab, put in, it's a good idea to put in the date that the sample or the date that your analysis was taking place. What is the actual output that you're measuring? In this case, it's product weight. Now keep in mind for control charts, typically speaking, an ImR control chart is a continuous output, meaning it's something I can measure: time, temperature, weight, pressure, dollars and cents, that sort of thing. Okay, so something I can actually measure. Um, and the process area, where am I taking the sample from? So in this case, it's a factory in Toronto. Who did the analysis? And then there's two other fields that you don't have to fill out. That's expected mean and expected standard deviation. So sometimes you have an idea of what's the mean, what should the mean be, or what should my average be, what should my standard deviation be. If you know it, feel free to put it in. If you don't know it, that's fine. You can leave it blank. There's some small differences in calculation that'll take place if you have it filled out versus not, but we're not going to get into that. So for now, I'm going to leave it blank. The second tab you now go to, which looks a little busy, but basically wherever we have a yellow shaded area is where you want to fill out your data. So I'm going to try to zoom in a little bit here and scroll over. So hopefully you can see that. So on the far left-hand column, you've got an ID, and that's just a chronological ID of the data points. So this was the first data point I gathered right here at a weight of 31, let's call it grams, and then 45, 39, so on, and it's chronologically gathered. Okay. As you pop in your data here, right, you can paste it in or whatever you want to do, and you can basically pop in a lot of data here. Okay, so I've only got in about 63 data points. Let me just zoom out a little bit. And when you do that, it automatically populates the data onto this ImR control chart. Okay, so individuals and moving range control chart. So a couple things to think about when you look at these control charts. The first thing you'll notice is that there's a green line through the center and two red lines, one above the green and one below the green. So the green line is your average of that sample population, okay, that you've taken. That's the average of all those data points. In this case, it's 40.46. Let's say it's grams, okay, because it's product weight. And then you have something called the upper control limit and the lower control limit. Now, it's important to stress here that the control limits are not spec limits. This is not your company or your customer saying this is the spec limits, the tolerance. It's nothing to do with spec limits. The control limit is basically a statistical calculation of, based on the sample you've taken and the average and the standard deviation and how it's varying, and using some statistical constants, it calculates upper and lower limits of where the variability should be if I have a stable process. Okay, that's kind of how they're calculated. Now, it looks really busy because on the right side here, there's the control limit math. If you're really interested on how we got these control limits, well, it's there. Okay, and we're not going to get into it today, but just know that the upper and lower control limits kind of are above and below the mean, and well, typically above and below the mean, and they represent where normal variability would be found in your process. If I have any data points that fall outside of the control limits, those are in fact an example of what we call a special cause outlier, or some special cause. Something happened that brought your process out of control, out of stability. And you can see that this data set and the Excel file automatically tracks when I've got an outlier. So this data point number 6, 7, and 8, it's telling me there's outliers. And sure enough, there you go. There are outliers, right? There's the outliers right here, 6, 7, and then 8 down there. Now, Um, the other thing you'll notice here is that it actually go back here, has another weird point here. So this there's a shift in the mean. So see, it says special cause ind shift, which is individual shift, or special cause individual outlier, special cause individual outlier. If it's MR, that means moving range. So there's a moving range that went out of control right here. So data point 8, in fact, is actually referring to the moving range chart that's out of control. Okay, so it's really, really quite good. The tool populates a control chart for you right away, which isn't always easy to do in Excel, but it does it for you right away. It even gives you some very basic statistics around the sample. So what's my mean? What's the variance of the sample, the standard deviation, skewness, kurtosis? We're not getting into all this stuff, okay? Median of the sample and so on, okay? The other thing it does is it actually calculates a few other little tests for you, like the normality test, which is super important for doing other types of analysis down the road in Lean Six Sigma. But let's look at these other quick tabs before we kind of stop this video. The histogram, it automatically populates what a histogram would look like for that data sample. And you can see that there's a bit of a skewness to this data set. There's a lot of frequency of data points kind of in this range, and then it kind of tapers off, right? So this is a very skewed data set, and that's fine. This is part of the reason of looking at the data this way, is to figure out what's the variability look like of my process, okay? Some other descriptive statistics I found right here. And then finally, a normality test. Now, again, without getting into all the statistics, it takes the data from this sample you've given and automatically puts it into a normal probability plot to see, is my data normally distributed? And this is important because when you do other analysis in Lean Six Sigma, a lot of those analysis typically are only able to be done if the data is normally distributed. So this is telling me by the looks of it, and also by, we often look to this p-value, right? If the p-value for my normal probability plot is less than 0.05, right, then you have to conclude that your data is not normally distributed. That's just the way it is in Lean Six Sigma and how we interpret these graphs. But in case you forget that, the interpretation is right here, right? It even writes it out for you. If the p-value to the left is less than or equal to 0.05, you may want to use this control to transform the data. Now, I'm not going to go through and transform the data, but the tool allows you to say, well, let's try a few different types of distributions to try to make this normal. And all you're doing is you're transforming the data to make it normal so that eventually you can do some analysis. So that might be a little bit out of the scope of kind of what I want this video to cover, but what's helpful is you can plot your data nicely on a ImR control chart. You can see your mean, your upper and lower control limits to see if your process is stable. And then, of course, you can look at it. What does the distribution look like on a histogram? And finally, is my data normally distributed or not? Okay, so that's it for this quick video. I want to thank you for listening, and keep in mind that there's other Excel tools that you probably already have access to that you've downloaded, and I will be sharing a video about how to use those tools shortly in case you don't know. And there's a whole suite of Excel-based tools that are at your fingertips if you want them. Again, way more affordable than running it through Minitab or Jump or any other statistical software. And Excel is a tool that everyone loves. So check them out when you get a chance. Okay, that's it for now. If you got any questions, drop me a line or drop me an email. Be happy to answer them. And we'll be in touch. All the best.